Hey guys, Mr. Regan. Today we're going to look at solving systems of equations using multiplication and then elimination. So we've learned how to solve systems of equations using elimination when we have coefficients in each of the equations that are the same. If they're the same and the same sign, we know that we subtract the equations. When they're the same coefficient but the signs are different, then we know we add the equations. Now we're going to be looking at equations where we don't have any coefficients that are the same. So what we're going to have to do is multiply one or maybe both of the equations by a number so that we can get the coefficients the same. So if I'm looking at these two equations, I notice that I have a 3y here and a 9y here. And I could easily take this equation and multiply the whole thing by 3. And then instead of a 3 here, I'll get a 9 here. So I'm going to do that. I'm going to multiply this 3 by everything in there. So I'm going to get 3 times 3x is 9x, plus 3 times 3y is 9y, equals 3 times 9 is 27. And then I'm going to copy down my other equation, because there's nothing wrong with that one. 2x plus 9y equals negative 1. And now I have exactly what I wanted, coefficients that are the same. They're also the same sign, so I'm going to subtract. So 2x minus 9x is negative 7x. They will cancel. Negative 1 minus 27, negative 28. I'll divide each side by negative 7 to solve for x. That cancels. X equals positive 4. Alright, now I need to find my y, so I can plug this into any of my equations. I can go into that one, or even this new one down here, either one. So I am going to choose the top one. That seems the easiest. So 2 times, I'm going to substitute 4 in for x, plus 9y equals negative 1. 2 times 4 is 8, plus 9y equals negative 1. Let's subtract 8 on both sides. That cancels. 9y equals negative 1 minus 8 is negative 9. Divide both sides by 9. That cancels. And y equals negative 1. So then my solution is going to be, my x coordinate is 4, my y coordinate is negative 1, 4 comma negative 1. Right, so I had to multiply one of the equations so that I could get coefficients the same, and then I just used my elimination method. Alright, let's try another one here. 4x plus 5y equals 7, 3x minus 2y equals negative 12. Alright, now this one looks a little trickier because I don't see a way to just multiply one of the equations by a number and easily get the same coefficient. You know, I have a 3 and a 4, I don't see anything there, and a 2 and a 5. I mean, yeah, I could multiply 2 by 2.5 or 2.5, but I want to try and stay away from fractions and decimals. It gets a little ugly there. So now I'm going to have to actually multiply by, or both equations by something. So it's real easy. If I wanted, let's say, the 4 and the 3 to be the same, I could multiply the bottom equation by 4 and the top equation by 3. That would give me a 12x on the top and a 12x on the bottom. Pretty easy. But I'm actually going to work with the 5 and the 2. So I'm going to multiply this top equation by 2 and the bottom equation by 5. Okay, now I could also put negatives in here, and that way I could change up the problem when it comes time to eliminate on whether I want to add or subtract. But I'm just going to leave it as 2 and 5 for now. So 2 is getting multiplied by all of that. So 2 times 4x is 8x, plus 2 times 5y is 10y, equals 2 times 7 is 14. And be real careful. A lot of times people forget that last part. All right, multiply 5 by all of that. 5 times 3x is 15x. Oh, that's not a plus. Minus 5 times 2y is 10y. And 5 times negative 12 is negative 60. Alright, so now I have this 10 and this 10 One's plus and one's minus. So I'm going to add these two together for them to cancel. So 8x plus 15x is my 23x. They will cancel. 14 plus negative 60 is going to be negative, 46. I'll divide by 23. And x will be negative 2. And I'll take that negative 2, and I can substitute it into any of the equations. That one, that one, that one, or that one. So I usually like to, try the easiest one. And the first two seem easier because the numbers are smaller, so it doesn't really matter. I'm going to choose this one. So I'm going to do 3 times negative 2, substituting negative 2 in, minus 2y equals negative 12. 3 times negative 2 is negative 6. Minus 2y equals negative 12. I'll add 6 to both sides. That cancels. Negative 2y equals negative 6. Divide by negative 2. And y equals positive 3. So my solution, x was negative 2, y was positive 3. Negative 2, comma 3. All right, then we're going to do a word problem. Keith Valley Middle School put on a musical. On Friday night, they charged kids $5 and adults $8 and made $600. On Saturday night, they charged kids $3 and adults $10 and made $620. Each night, they sold exactly the same number of kids' tickets and exactly the same number of adult tickets. How many kids' tickets and adult tickets were sold each night? All right. So I know that I'm going to be writing equations. I know it's going to be 2 equations because I'm solving systems of equations. So my first equation will deal with Friday night. So I'm going to use x for my kids' number of kids' tickets and my y for number of adult tickets. So Friday night we charge kids $5, so 5x, plus we charge adults $8, 8y, and we made $600. Okay. On Saturday night we charge kids $3, so 3, and I'm going to use the same variable x because it said the same number of kids tickets each night, same number of adult tickets each night, so I know those x's are the same. Plus, the adults got a little bit more that night, $10 per ticket, 10y, and they made a little bit more money that night, $620. All right, so now I'm going to use my elimination method to solve. I noticed that I don't have any coefficients that are the same. I also noticed that I don't have any numbers that are easily multiply one equation by to get a coefficient of another, so I'm going to have to handle both equations. So I'm going to deal with the 5 and the 3. I'm going to multiply the top equation by 3, the bottom equation by 5. When I multiply the top equation by 3, I get 15x plus 24y equals 1800. When I multiply the bottom equation by 5, I get 15x plus 50y equals 3100. Alright, so now I have a 15x and a 15x. They're both positive, so I'm going to have to subtract these equations. And 15x minus 15x, that cancels. 24y minus 50y is negative 26y. And then 1800 minus 3100 is 1300. I'll divide each side by negative 26. I'm sorry, negative 1300. That cancels, and I get a positive 50. 50, there we go. So now I'm going to substitute y is 50 into one of the equations. Once again, easiest one, I don't know, probably this first one here. So I'll do 5x plus 8 times 50 equals 600. 8 times 50 is 400. So 5x plus 400 equals 600. Subtract 400 on both sides. That cancels. I'm going to come over here. 5x equals, 200. Divide by 5 on both sides. And x equals 40. So how many kids tickets, how many adults tickets? Kids, we sold 40. Adults, we sold 50 each night. There you go. So there's solving systems equations using first multiplication, then elimination. Sometimes you can get away with just multiplying one equation by a number. Sometimes you need to multiply two equations. And then you saw an example of a word problem, how to set it up and use elimination. All right, good luck, guys.